Welcome to the robot game. One of the most critical elements of the robot game is making sure your team has a thorough understanding of the game rules, including mission model setup and scoring positions, definitions of terms such as in, on, and touching as they relate to the robot game, penalties, and robot size restrictions. There's nothing worse than getting to a tournament and discovering that one of your missions is blown because someone read the rules wrong. Best practice is to read, discuss, and read again. You may also want to post a copy of key rules and definitions in your work area and appoint a rules expert for your team. And remember, if it doesn't say you can't, then you can. Once you know the rules, you can start to strategize. The two main components of robot game strategy are prioritizing missions you want to try and grouping missions together for more efficient runs. When prioritizing missions, you want to consider things like point density, time to run, and complexity of tools and program required. When grouping missions, you want to consider table location, similar tools or attachments, and prerequisites. An example of a prerequisite would be the pig from the Animal Allies season. You need to collect the pig, add a part while the pig was in base, and then deliver the pig in another mission. The chassis is a means by which you deliver the tools you will use to complete your missions. So, do you build the chassis first and design the tools to fit, or the other way around? The answer is that you do what works best for your team. For efficiency, you will probably do some of the work simultaneously. To get started on the chassis, it's helpful to make a list of design requirements. Do you plan to use sensors? Is there a preferred location for the sensors you plan to use? What's the smallest space the robot will need to drive through? Are there any height or other requirements posed by base? What type of wheels are best? Also, make sure you can access the power jack and the programming jack, and that you have enough room for wiring. There are many different instructions available online to help you get started. You can use one of those, modify it, or custom design on your own, depending on your team's comfort level and ability. Another component is brainstorming solutions. This is something you may want to do before finalizing your game strategy, as the solutions you choose will impact complexity. Encourage your team to get creative and think about tools they use and see at school, in the kitchen, in a workshop, on a construction site, or even in a sci-fi movie. Also, solutions can be passive, such as an axle sticking out that flips a switch, mechanical, such as a trigger, or motorized, such as a forklift. Once you have an idea, it is best to build a prototype that will prove that the idea will work to solve the problem. Prototypes should be fast and hand-maneuvered to interact with the mission model. This way, potential problems can be uncovered before spending too much time. Several iterations may be required before you get a working solution. The beginning of the season may seem mechanically heavy. However, there are also programming tasks you can complete. First, work on basic programming skills. You may want to rotate team members through working on tutorials during the first several meetings. Also, you can have your team create MyBlocks. MyBlocks are pieces of code that can be saved in a single block, which can then be used over and over again in your programs. You can build MyBlocks for actions such as line following, wall following, or any other repetitive action that takes more than a few blocks of code. Creating and testing these blocks early in the season will save you a lot of time later on. Now that you have your chassis, your tools, and your strategy, it's time to put it all together. There are several tips that can help this effort go more smoothly. Creating a standard method for attaching tools to your chassis will save your team a lot of time on transitions, leaving more time for completing missions. Some successful methods are sliding attachments onto axles or using magnetic Legos. Creating a flowchart or other organizational representation before starting your program is a good way to get on track and stay there, even if you get bogged down at some point in the middle. Using a jig or other reliable method to make sure the robot starts from exactly the same spot every time you run is critical for reliability. As you go, a group working on one mission may want to make a slight adjustment to the chassis. Even small changes to the chassis can make a big difference on how the robot behaves. Make sure you test the change with all runs to make sure they still work before finalizing the change. While this video gives a fairly thorough overview, there is a great deal to consider when working on the robot game. Fortunately, there are many resources available online. Using tutorials, sample building instructions, and good process practices will help your season be more successful.